Hello, in this video, let's talk about the synthetic division of polynomials. So we can use the synthetic division to find the zeros of the polynomial, and sometimes on the homework or on the test we would be asked to prove that some number really is a solution, and the only way to prove it mathematically is to use a division. We can either use long division or synthetic division. Synthetic division is a lot faster and easier to use. So let's use synthetic division. But first, to know what we're going to divide by, we need some guesses. And to get the educated guess, we use the calculator. So the calculator, we simply type in the equation, and here it's already typed in, x to the fourth minus 6x cubed plus 5x squared plus 24 minus 36. And here's the graph once again. Let's redraw it. And it's on the standard window from minus 10 to 10, counting by ones. So from the picture on the calculator, it looks like -2 might be a good guess for the 0, and then something between 2 and 3, and then looks like maybe a 3 again. Maybe 2 or 3. But let's get the calculator to actually tell us what those answers are. So calculate, let's find the 0 of, let's say, some positive solution. So here is left side, right side. Let's see what that first positive is. It looks like 2. Wonderful. So that means that if we suspect from the calculator that we suspect that x is 2, might actually be a 0. So to prove that it is, we do the division. Now, synthetic division is done with only the coefficients. So we will need -1, -6, plus 5, plus 24, and then minus 36. So, and the procedure for synthetic division is we add down and we multiply diagonally. So what that means here is what that means as a procedure. So we write the coefficients 1, -6, 5, 24, minus 36. We have to make sure that all the terms present in descending order, so the highest power comes first, then the smaller one, and all of them have to be present. If the square was missing, we would put 0 in place of that term. If the x was missing, we would put 0 in its place. It's very important to keep all the places. And then we are dividing by what we think the solution is, which is 2. Now the process goes like this template says. We add down. 1 plus nothing is 1. Then we multiply diagonally. 2 times 1 makes 2. And then we add down again. -6 plus 2 is -4. Multiplying 2 times -4 is -8. 5 and adding 5 plus -8 is -3. 2 times -3 is -6. 24 minus 6 is positive 18. 2 times 18 is positive 36. Adding them together makes 0. 0 is the remainder. So what we have just done is we have divided and we have proven that x equals 2 really is a solution. Now, what we have really done is we have divided this polynomial by an x, which means all of these powers got reduced by 1. So this is the fourth. These are the numbers that go with 1 power less than what we started with. So these are really the coefficients of 1, that's x to the third, minus 4x to the second, minus 3x plus 18. That's the remaining polynomial. It has 3 solutions. So we were promised 4 by the fundamental theorem of algebra. Here is 1. The other 3 are here. We can do another synthetic division to see if we can find another solution with 0 remainder. So we copy the same coefficients, 1, -4, -3, 18. Now, what is another good solution? On the other side, it looked like perhaps -2 might work. So let's actually use a calculator to see if that's a reasonable guess. So here, let's scoot over to the left side. There it is, left side, and then right side, guess in the middle, -2. It really does look like -2. But to prove it, we have to do the division. So let's do the division by -2. Following the same procedure, we add down. 1 plus nothing is 1. -2 times 1 is -2. -4, -2 makes -6. -2 times -6 is positive 12. -3 plus 12 is 9. -2 times 9 is -18. And 0 is remainder, which proves that x equals -2 is also a solution. So we proved that x equals -2 is also a solution. And we started off with a cube, we divided by x. These are now squares. So this is the same as having 1x to the 2 minus 6x plus 9. Well, the other two solutions are here. Well, that happens to be a quadratic function, and we can solve it using quadratic equation. We could also solve it by continuing to do the synthetic division if we can find a suitable point to divide by. So let's go back to the calculator and see if perhaps we can find us some new guesses. So calculate, we already found the negative side, we found the first positive. Let's have a look and see what the calculator says about this last positive. Now the graph bounces off of that point, which means it has an even multiplicity. And it says 2.999. It is probably an approximation error. Most likely the answer is actually 3. So let's test the 3. That's the difference between doing the work by hand and with the technology. So we'll try 3. 1 plus nothing is 1. 3 times 1 is 3. -6 plus 3 is -3. 3 times -3 is -9. 0 remainder, which means yes, x equals 3 is actually a solution. Which leaves us with 1x minus 3. That's the only expression to solve. Adding 3 to both sides, we find that x is 3 again. So 3 again happened twice, and the other two solutions are +2 and -2. So using the synthetic division, we have found 4 solutions, just like the fundamental theorem of algebra promised. 4 solutions, -2, +2, and then 3 happened twice, so multiplicity 2. And that means that we have 3 and 3 again, total in 4. So that's the answer to the question. Using synthetic division, find all the 4 solutions. And that's it for this video. That is the procedure we will be using when we do the sketch of these polynomials by hand. We will use the calculator to get a good guess, and then we will use synthetic division to prove if it works or not and see where else the remaining solutions are. And that's all for this video. Thanks a lot. Take care.